Hi everyone, welcome to our talk. We are going to share with you some lessons learned when building our in-house framework. First, I have a question for you. What do you think this number could stand for? I can spoiler, it's not the amount of people that travel from Karlsruhe with us to Berlin today. It's actually time saving. Time we save when building apps by using our framework. With Flutter, we already have the possibility to save time because we only build one code base for iOS, Android, web or desktop apps. But with our framework, we have additionally the possibility to build high-quality, customizable apps for a lower price and lower time. This convinces our customers to work with us because they need to pay a lower price, but also our Flutter team can work towards a common goal. Before we introduce ourselves, I want to get to know you a little bit better. So who of you has developed an app before? Okay, as expected. Who of you has developed more than one app? Okay, quite still everyone. And who has developed a feature more than once when developing those apps? For example, login, push notifications. Okay, so you will know what we will be talking about here. So I'm here today with Pascal, who is a Flutter engineer since 2019. His passion for Flutter development is not only shown in his daily work at Gem Labs, but he is also the Flutter meetup organizer in Karlsruhe.
And this is Marina. Marina did not only introduce us to our presentation, but is also our Flutter team lead at Gem Labs and has experience of about 8 years in mobile development. As said, we are both from Gem Labs. Gem Labs is a digital agency located in the heart of Karlsruhe in the beautiful Höpfner Castle. And we are proud to celebrate our 10th anniversary this year and our 3rd Kununu Top Company Award in a row. We are about 40 team members, and 11 of whom are currently Flutter engineers. We have many different customers in different market sectors. They are in energy, in banking, finance. But we noticed that a lot of our customers, whether the sector or how large the customer is, the apps share a lot of similar features. And that's where our journey for in-house framework started.
Okay, so let's start with the journey of Flutter at Gem Labs. Our first Flutter app we built in 2020. Flutter was still pretty new. We started with version 1.0 and we didn't have any standards yet. For Android and iOS development, we had developed multiple apps. We knew how a base architecture should look like, but for Flutter, it was still pretty new. So we had to decide, for example, for a state management. Should we use set state? Maybe that's too low level. Redux, MobX, or block with qubits. So many things to look at and to try out. Also, how should we handle navigation or assets? Over the next years, with every app we built, we refined our standards. We had different people on our team, some with Android background, some with iOS background, and everyone had their own idea of how a base architecture, how our standards should look like. And also Flutter and Dart got new versions. So I remember, for example, when Dart define from file finally solved our issue for different build configurations, which was pretty neat. So over those years, we developed many apps, and the problem was, or the challenge is, that every app was different. In every app, we tried something new. We used a different navigation, for example, or different state management just to get to know all of them. And the problem is when you decide on a new standard, you usually cannot go back and refactor all your old apps. So you cannot go back and tell the customer, okay, we have a new standard, we need to implement it new. So it was hard to maintain because when you switch projects, the implementations were all different. Also, we started every app from scratch. So we had some kind of base architecture for the main files, but still every project was new and we weren't really able to reuse lots of the components we used. So by the end of 2022, we decided to build a framework to overcome all those challenges. We wanted to provide better quality and better developer experience. The result was our Cemid Labs foundation, Flutter, which should be one base for all our apps. The key goals for our frameworks are maintainability. So every bug fix, every improvement we make for features should benefit all of our apps. So the system should be easy to extend and to interchange with new components. I remember a couple months ago where we had to update all of our apps because the required API declaration for iOS. So we had to create the manifest in all of our apps or update the dependency to include those manifests. And we just had to do it once in our framework and all of our apps got the update. So that was pretty neat. Next key goal, testability. All of our components in our framework should be testable as automatically as well as manually. And last but not least, reusability. Every feature we develop should be easily integrated into apps. They should be reusable, but it should still not feel like for the customer that he gets an app like every other app. So we can reuse components, but still every app should look different. The customer should be able to bring their own CI. So Pascal, when you first heard of the idea that we want to create a framework, what were your thoughts?
Good question, Marina. Actually, I thought, is it even possible to extract or combine all UIs we have in the different apps into a package? Because the apps all look different, or do they? Actually, no. Like, they look different, the pages look different, but the basic components are all the same. Every app has buttons or a calendar. Also, we noticed that most apps have some kind of authentication, whether it's OAuth, a password grant, in-app authentication, or anonymous auth. We can extract the auth layer into one package or multiple ones. Also, we noticed that a lot of our customers are from the middle market sector and they don't have huge budgets for custom backends. And so they use Firebase or Supabase. And we can also extract the domain and data layers which talk to these backends. So where do we begin with extracting and building our packages? First of all, we decided that the app size doesn't care for us. Every app we are building with Flutter is built with our package system from the ground up. So when the customer has only a budget about 50K or $1 million, every app uses our package system because they benefit from it. On the one hand, they get the packages we already built, and it's really fast to just configure them in the app. And the packages are also field tested with apps which are on the Play Store right now. On the other hand, every app which uses our package system directly implements new features or complete new packages, which we then can reuse in new apps or apps we currently have. So what can we really extract into these packages? On the one hand, we can extract little atomic widgets like custom buttons with loading indicators or a calendar. Okay, a calendar is already more complex, but you get the point. Also, there are some pages which are completely reused in other apps, like an authentication page or a page with a searchable list. Furthermore, we have some common business logic with use cases like get a stream of a list of an entity. And we have some generalized data handling, especially for Firebase and Supabase. So we don't have to write the domain layer at all for them for that apps. And the data layer too. Then we also have some common utils like extensions on the build context or some functions for our theming solution. When we build these packages, there are some small but important concepts which help us that our packages are really flexible, can easily be reused, and are maintainable. So we split them into the typical layers like UI, domain, and data, which allows us or allows the packages to choose whether they want Supabase data layer or a Firebase data layer or a custom API. Also, we use a lot of interfaces and generics to make the packages even more customizable. But we also noticed that not everything can be extracted into a package. Therefore, we had to create an app template which defines some basic ground layer for every app. So if we write a new app, we just clone the template and it already defines which state management solution we decided on and how we do dependency injection. This directly impacts how we can, as a developer, switch or review other projects in our company because every app code looks basically the same. The architecture is the same. You know how the things are handled. Also, navigation is a part of it. And the basic theming setup, how our packages access the theme and some basic parameters which all our packages are built on. Localization is also a part of it, as well as assets. So we had to find an asset solution where we don't rely on or where we can't get any one-time errors because of an asset which we removed, but the static string still is in the app code. So we used Fluttercon here to generate objects for our assets, so we get compile time errors or compile time errors. Also, which or how we handle permission handling is defined. So we do it the same in every app again, but of course, which permissions an app requires is really specific to the app. So there's a short list of the packages we decided on. That's just personal preference. I mean, there are many other great solutions you can use. Yes. Then we have some stuff which is really, really app specific, like the colors which are used in the app. That's different for every customer. They have multiple themes, and the themes can also include fonts. Also, the domain models are completely different, or most of them are completely different, because the customer has their database already defined, or has specific properties from a time tracking app. The properties are different to a mobile app for some client in the energy sector. Also, many of our customers use Supabase or Firebase. There are also some creator customers, bigger customers, which have their custom backend, or also small customers sometimes. And then we have to write the API connection completely new. Of course, we also use the same packages here every time, but for every REST endpoint, but the endpoints are different. And of course, as already said, the pages in the apps are also different because the order of the components is different, what components the customer wants to use, and stuff like that. So we decided on our packages, how we create them, what we can't extract in our packages, and what has to be done in the apps itself. And then we started to create our first packages and soon faced our first challenges.
Thank you. So let's first start with how to build UI. We want to have generalized screens and widgets that are reusable, but they should still be customizable for the customer. So I brought an example. Here you can see our login screen component. You can see that we have two different designs, different font, different text sizes, different text fields, different button styles. And still, it uses one generalized page in our framework. So at first, we just moved code we had built in an app to a package. But soon we noticed that it's not flexible enough to exchange the components. Let's start, for example, with a text widget. Here we have on the left side the sign-in or the login title. For example, we can have it headline medium or headline large or even something smaller. So how can we build the screen to have this title exchangeable? At first, we defined the text widget directly in the login page in our framework. The problem is that the style of the title was hard-coded inside the page, in this case, the headline medium. That was bad. So next step was to not define the widget inside the page, but to pass it to the page. And still define a default text style in our page. So you can either pass just a text widget with a string and can use the default style, or you pass your custom style. So in this case, we have the headline medium style as a default style if you just do nothing, but you could also override it. You can override it in two ways. So either you define your text style for headline medium in the app theme. So the advantage of using material components is that you can style all your components from the app theme. So you can define here also if the headline medium should differ from the standard and give it some custom configuration. If you don't want to use the headline medium style because you don't want to change it everywhere in the app, you just want to change it at this specific place, you can also change it in the login page where we pass the widget. So there you can also set a style again for this text. In this case, I passed the headline large, so we customized it. For text, it's pretty easy because text is always the same widget for displaying it. But for buttons, for example, it's more difficult. For buttons, we have different widgets for different looks. So we have an elevated button, a text button, so it's not that easy. To solve that problem, we created a class with some static types where we return the button type. So for example, an elevated button or a text button. Like this, we can configure the page to use some specific kind of button. Here you can see an example of the login page configuration. We first pass the text widget for the title, and then we pass the types of buttons we want to use on our page. So for example, the login button should be an elevated button, or the privacy button should be a text button. Inside the page, we just use the passed widget. It's actually a widget again that we pass, but by type, and then set a text and a callback. Here you can now see a full integration example for a login page. So we include our component, the JLFF login page, and configure it. We set the title, we set the button types, we define some callbacks, which we need to override in the app, but that's all we need to create this page. Of course, the logic would be a different component that's behind it, some different kinds of authentication. That would be then the domain package or data package for the login. Now that we've showed you how we do our UI, let's dive a little bit deeper into our architecture.
Thanks, Marina. So when we started with JLFF, we had one package for all our code we had. And of course, that was awful, but it was fast and simple. So it was the best solution to start. Okay, it was not the best solution because we had to redo it. So we split our packages into different categories, like our resources package or folder, which handled all the data communication, like use cases or the connection to Firebase, Supabase. Also, we created then a package for authentication, a searchable list, and so on. But we noticed that when we had the different implementations for the same point, like Supabase or Firebase for data handling, one customer of us don't need both in the same package. And when both are in the same package, their dependencies have to be compatible with each other. So if we upgrade, for example, the Firebase package, and the Supabase package doesn't work with the new requirements for their underlying packages, we have a problem. So we split our packages in the different layers. And so we gained over this 200 packages we currently have. Now we have UI packages, domain packages, and different data packages. An example of how we use these packages is this calendar page. Our goal here is to show the calendar with some different events from Supabase. So when we have a page like this from our design team, we first think about which packages we currently have and which packages we can reuse. Also, our design team knows which packages we have and tries to build the different screens with the packages we already have. So we can just reuse them and configure them. In this example, we can use the JLFF calendar package, our get resource list use case from the domain package, and our Supabase data package. Then there's some custom logic which we have to define in the app itself, like the page, the state from the page, the qubit, and the calendar event with some helper functions, which I will show you on the next slide. So first, we define the custom entity we have. In this example, it's the calendar event where we use freezed because we defined that we use freezed for all our entities. It works really great with qubits and states. And we then defined the different properties with from and to JSON converters because the APIs communicate with JSON data. And from JSON method, exactly. Then we need some helper functions because, as said, we don't want to create or write code for the data or domain layer new. So we just have this data, this helper functions which implement our resource layer interfaces for to JSON and from JSON. Here, an important part is that we have to create helper functions because on the one side, Freezed doesn't support inheritance. And on the other side, abstract classes can't have factory constructors. So we can't have a from JSON abstract class, which is implemented by our data classes. Then we also have to define which IDs or parameters we need to find the correct data table in our database. If we use an SQL database, like with Supabase or new, also with Firebase, we only have one ID because all the tables are on the same layer. But if we use a NoSQL database, for example, we could have a more complicated path like the one on the right, where we have account, an account ID, and then a subpath of it. So here it's only the ID we define. And then we also have to define what the primary key of the table is, what the name of the table is, and also the builder function for the path which uses the attributes. Then, when we defined all these helper classes and the entity, we provide our data and domain packages in a repository provider. So on our apps, we have a repository provider around the complete app, which provides all use cases, data layers, and then we can just reuse them on the UI level, so this qubits and states. Also, we provide the resource list use case, so we can fetch the calendar events from the server. Then we just have to call this use case from our qubit. In this case, it's the get resource list use case with the generic types calendar. Oh, now they are not generic types, but we give them as generic parameters, calendar event and calendar event SQL path params. We call the use case. In this case, the ID says not used because our packages require an ID, but because we want a list, we don't have a single ID. So we just say the parameter is not used. Then we can define filters and order by functions, which we already defined and declared in our packages. So we don't have to rewrite them again and over again. In this case, we take all the events from the user, which are in the future, and sort them by the start date. Also, we use multiply result for all our functions, which could potentially throw an error. But because we don't want to forget a try catch block or any exception which could be thrown, we use multiply result. There's also other packages which can do this, like the either type, but we work really fine with this package, and it helps us a lot to reduce the amount of errors we forgot to catch. So we have to handle them. Now, after fetching the response, we can emit the state for the new qubit and use the JLFF calendar value constructor now to render these items. Here you can also say that a lot of our packages use builder functions because builder functions are really flexible and give us the option to define custom entities, custom widgets, which are built on a specific layer of the page. Also, when we have a page predefined layout in one of our packages, we maybe then have 4 or 5 different builder functions for the title section, the bottom section, and so on. Nice. Now we use the builder functions, and our beautiful calendar widget page is here. And as said, this package is easily customizable because we have our defined theme. It works with the material theme. You can just switch the colors or the forms of the different events. We have it field tested on apps which are already currently on the Play Store from other customers or the customer itself with another app. And it works directly on mobile and web, so you don't have to test it over and over again for the different platforms because we already used it there and so on. Now I showed you just a small amount of our packages, like 4, I guess. But as said, we have over 200. And that our packages are scalable and they can grow in the amount even further on. We have to manage them in a way which is scalable. And Marina will show you how we do it.
Thank you. So now we need to talk about package management because we have all those packages and need to cope with them every day. First, we started off using a mono repository with Melos. Who of you has used the mono repository before? Okay, also quite a few. It was easy to set up. We were pretty fast ready to start working on different packages, but it had some disadvantages for us. First disadvantage for us was the single commit history, because you have a commit history for all different kinds of packages. Here, for example, you can see that we added a PDF renderer or created a code viewer, so it's all in one history. Also, you could change multiple packages in one commit because you just don't have a boundary. You can just change multiple places. So we don't have an enforcement that you just touch one package. Also, you have to give access to all the packages at once because they're in one repository. And also the repository got too large and we ran into some performance issues. We then decided to switch to a multi-repository with Git submodules. Who of you has used a multi-repository before? Okay, few less. For the Git submodules, we have the advantage that every package is its own Git repository. As you can see here on the right, we have an own history for every package. We can have version tags, and it's pretty clean and straightforward to see what has changed. And you can also give access only to simple single repositories. Challenges with this approach is, of course, that it's development overhead. You have to create multiple merge requests when changing a package because you need one for the submodule and the main repository. And also setting up the CI was a bit challenging because we didn't want to have to clone all the pipelines for every package. So we had to find a solution there, which we did. We also wrote some custom scripts around that because we don't have Melos anymore doing it for us. But all in all, this is now the solution we want to scale with. How do we include the packages into our apps? First, we started with this one Git repository. So we included them by Git. So using commit hashes or version tags. The problem with that approach was that you don't have version solving. So it was pretty much effort to think about which versions can be used with what other versions from other packages. So now we introduced a private package server where we host those packages, and we can just include it as usual in the pubspec YAML. We just have to define our server URL with the hosted attribute. So now you have an overview of our framework, but we're not done yet. So I will pass to Pascal.
Thanks. Yeah, as you all know, software is never finished. So we are shortly going over the points we're currently working on. One of them is, of course, increasing test coverage. I guess it will be the same on all of your projects. Also, we are always working on improving our documentation, especially with this amount of packages. When new members join to the team, it can be hard to for them to know every package and how they are used. So we have to improve our documentation ever on. Also, the discoverability of our packages is or was a real problem. And if you have any ideas how we could do this in a perfect way, please come to us and speak with us. Because when we have this amount of packages, it's always important that we know we already have this package. We don't have to rebuild it. And also our design team knows we have these packages. We can use them and not design it from the ground up or create it from the ground up. Also, our velocity can be improved even further, just with the change to submodules, which comes with a little bit of developer overhead. We can use some custom IDE plugins, some custom scripts, and also a refined CI/CD with more pipelines and better steps to improve our velocity. But we are near to the end of our talk, but we won't let you go without some final takeaways. And Marina will say them to you.
Okay, now you've heard a lot, so let me summarize. We use material widgets for easy theming and customizable UI. We want to keep our UI domain and data layer separated and generalized, so it's flexible to be used in different apps. We use a multi-repository for managing our packages because it's clean and transparent. And a package server for version solving. At the end, building a framework pays off. It saves costs and time when building apps. The packages are tested and can be reused. And with every app, the framework grows and improves. And maybe the biggest learning, you cannot start with a perfect plan. We started, we still learn, and we improve on the way. So thank you for your interest in our talk.